What do you need? What? Your homework. I'm just going over the problems in the homework, so go ahead and get your homework out. What? The homework worksheet, yes. So, guys, when I'm talking, when I'm teaching, I need y'all to not talk because I'm recording off my laptop so I can post it online. All right. So, this quiz review, I'm gonna be doing this before every test and quiz. It's just gonna be a bunch of either homework or notes problem or a mix of the two, whatever it is, that I think will be good to know for the quiz or test the next day. So I'm gonna start with number 6 on the homework. It's just a basic graphing problem. So I have 2 times x minus 3 squared minus 1. So anytime you want to do a graphing problem, what I'll do is I'll make a table. And I would start with the vertex. So you're given the vertex right away in the equation. I know my vertex is 3, -1. I'm going to put that right in the middle. When I put that right in the middle, I'm going to choose 2 points smaller than 3 and 2 points bigger than 3. So let's go with like 4 and 5 for 2 points bigger than 3. And I'm going to make sure the points I choose smaller than 3 are just as far from the vertex as the ones I chose that are bigger. So from 3 to 4, it's a distance of 1. So I'm going to choose a point that's 1 smaller than 3. Same thing from 3 to 5, from the vertex to 5, that's 2 away. I'm going to go 2 away as well, from 3 to go to 1. The reason I'm doing that, or basically what I'm trying to say, is don't choose random points. Make sure there's some kind of like rhythm to it, because this 4 and 5, they're reflections on 2 and 1. So you only need to solve for y twice. So like for 4, I can plug 4 into this equation. I get 4 minus 3 is 1. 1 squared is 1. Times 2 is 2. Minus 1 is 1. I just plugged in 4 for x. Everyone okay with that? Okay, it's good that it's easy. All right, I put in 4 for 1. When I put in 4 for 1, this is a reflection of 2, so that's also 1. I put in 5 in for x. I get 5 minus 3 is 2. 2 squared is 4. 2 times 4 is 8. 8 minus 1 is 7. And that's a reflection of 1, so you get 7 as well. So that's the reason why you don't choose points that are still equidistant from the vertex, so that you don't have to solve 4 different equations, just usually solve 2. So I have 3, -1, 4, 1, 2, 1, 5, 7, and 1, 7. Yeah, if you have questions, go ahead and ask. Yeah, so like on the quiz tomorrow, we're going to tell you guys plot 5 points. All right, so you can't just choose 1 point and just kind of throw some arrows out somewhere. You actually have to choose, you have to graph a certain amount of points. Like tomorrow, we're going to say graph 5 points. So we would want something like this. You do your vertex, pick 2 points to the right of the vertex, 2 points to the left of the vertex, and that's it. Any questions about that? Does that make sense? Go ahead. Oh, the ones on the y's? So like the x's, I'll plug them in. So like for 1, I would have 2 times my x value of 1 minus 3 squared minus 1. 1 minus 3 is -2. So you have 2, -2 squared minus 1. -2 squared is 4. 8 minus 1 and 7. So you're just plugging these x's into the equation. Any other questions here? Are we okay? All right, good. Yeah, so you put your vertex in the middle and choose a point 1 bigger than 3, choose a point 1 smaller than 3. The point 2 bigger than 3, choose a point 2 smaller than 3. Yes, I recommend that unless you have a denominator, or unless you have a fraction for a, then they'll be a little different, but don't worry about it. Any questions here? Are we good? All right, let's go on. Now we're on number 7 for the homework. On number 7, I'm asking you guys, what is the direction of the opening and the max or minimum value for f of x? So for this, I'm already given the equation right here. It's kind of sort of in vertex form. So the first thing I would always do is fix it to put it into vertex form. So I'm gonna put that k in the end. So I have 2 inside the parentheses. I'm gonna put that x value first and put that 7 at the end. So that's the first thing I would do, is I would fix it up so that you have everything kind of in the right place. So that's what we have for. After that, I have this negative in front of the x. Remember, I don't want a negative. I don't want anything in front of my x. My vertex form is y equals some a of x minus h squared plus k. Right, that's my vertex form. So I don't want any coefficient in front of x. So that 1 I'm going to factor out to get 2 times negative of x minus 4 all squared plus 7. And then from there, that b value, anytime you have a b, you can always apply the function onto b and combine it with a. So in this case, the function is that square. So I can square that negative 1, and I can multiply with a. Negative 1 squared is just 1, so it kind of just goes away. So what I get is 2 times x minus 4 squared plus 7. So that's kind of the first step. I'd always fix the equation first, so you know exactly what is my h, what's my k, and which way am I opening up or down. Everyone okay up to here? All right, so from here, I can see my vertex is 4, 7. My a value is a positive 2, so I know I'm going to open up. And problems like this, anytime we're asking about like the properties of a graph, I would always draw a rough sketch. So I know if I have a positive a value, I'm opening up. So I'll graph that little function here, and then I'll just graph the vertex of 4, 7. So I can see from here, well, I have a minimum at 7. Any questions about that? Does that make sense? All right. Everyone done copying? Ready to keep going? All right. Example 9, find the average rate of change for f of x equals 2 times x minus 4 squared plus 7 over the interval negative 3 to 7. So anytime you're talking about average rate of change, the formula for average rate of change is supposed to be a y. y2 minus y1 over x2 minus x1. That's the equation for average rate of change. So what I need to figure out now is that I have these x's. I know I want to find the average rate of change from an x value of negative 3 to an x value of 7. So I'm going to plug these x values into the equation to figure out the actual point that I get from this. So f of negative 3, that's going to be 2 times negative 3 minus 4 squared plus 7. That's going to be 2 times negative 3 minus 4 is negative 7 squared plus 7. That's 49 times 2. That's what, 98 plus 7, which is 105. So what this is telling me is that when x is negative 3 on this quadratic, I have the point negative 3, 105. That's what it's telling me there. And now I'm going to do the same thing for positive 7. So now I want to figure out, well, what's f of positive 7? Well, that's going to be 2 times 7 minus 4 squared plus 7. So I plug that in. I have 2. 7 minus 4 is 3. So I have 2 times 3 squared plus 7. That's 18 plus 7, which is 25. This is telling me that when x is 7, I have a y value of 25. Everyone with me so far? So those are my 2 points. And I want to find the average rate of change between those 2 points. So to be honest with you, it doesn't really matter what you make x1 or x2 or y2 or y2 or y1, as long as you're consistent with those points. So I can say, well, 25 minus 105 over 7 minus negative 3. 25 minus 105, that's negative 80. 7 minus negative 3 is a positive 10. So your average rate change is negative 8. Everyone okay with this? Does that make sense? Any questions about anything that I did before we move on? All right, let's keep going. Now we're going to problem 11. So on problem 11, parabola has been reflected across the x-axis and translated 2 units left and 4 units up to end with this quadratic right here. What's the original equation? So basically it's saying I started with some random quadratic, I don't know what it is. I did these transformations to it and I ended up with this one right here. But I want to know what the original one is. So to figure out the original quadratic, I'm going to kind of undo each of these transformations on this y. So the last thing I did was I moved 4 units up. So instead of going 4 units up, I'm now going to go 4 units down. So that means k is -4. So what I end up getting is y is going to be 3x minus 4 squared plus 2. Right, my k value is -4, so it's 6 minus 4, which gives you a +2. And then after that, I have a translation 2 to the left. That one's telling me that h is -2. This one can be a little confusing because remember, your h values, you put your h in, is always in the form x minus h. So if I have this x minus 4, what I have is your x, which is just x, minus -2. So it's minus that -2 minus 4, all squared plus 2. Which is really just saying x plus 2. You're really adding 2. So y equals 3, that's x plus 2 minus 4 squared plus 2, or y is 3 x minus 2 squared plus 2. Maybe I did this a little too many steps to kind of make sure you understand what's happening. But essentially, h is -2. So you kind of do the opposite of what you expect. You're going to add 2 instead. I had x minus 4. My h is -2. You think you'd subtract it, but instead you're doing the opposite. You're really going to add it to go up to x minus 2. Are we okay with that? All right. And then after that, the last thing I did is I reflected across the x-axis. So your x-axis is vertical reflections. So what I have is y is -3 x minus 2 squared, now minus 2. And that's what your original equation was. Any questions about that? Does that make sense? I know this one can be a little confusing because we're going backwards. Go ahead. Sorry? +2. What do you mean +2? Oh, no, because you have an A value. You have a vertical reflection, right? So guys, make sure you keep it down. So anytime you have a vertical reflection, you're reflecting all your y's. Your k is still a y, so it's getting reflected. So your A values have to affect your A and your k. So that's why the k became a -2. Any questions here, guys? Yes. What do you mean? Guys, keep it down. Guys, I'm recording this, so make sure you keep it down so they can actually hear me. Go ahead. It's not a dumb question. Okay. Ask me after I stop recording then. You're okay? Okay. All right, any other questions? Ready to keep going? Yes. So for the 2 units left. So you're going to, oh shoot, you're right. I did backwards. All right, so we're gonna backtrack this. Great start to this. All right. So we're gonna backtrack all of this. H is actually +2. It's my fault. H should be +2. So h is positive 2, so what you put in is a positive 2, so it's x minus a positive 2 here. So you add it together, you have x minus 2 minus 4 squared plus 2. I'm sorry. I mean, you should know me better. I always make these little mistakes. Sorry? All right, come to the tutorial then. Come on. You can do the next problem if you want. Actually. I don't know. It was a hard one. All right. So what you should get is 3x minus 6 squared plus 2. Then you have the a of negative 1 because you're reflecting it vertically. So what you end up getting is y is negative 3, x minus 6 squared minus 2. There we go. That should be the right answer. I'm sorry about that. Should have told me earlier then. I mean, you're in my class. You know I make these little mistakes all the time. Are we good? Thank you, Jenna. Sorry? Yeah. Thank you. Good thing, really. All right. You have your hand up? Oh, there you have your hand up. All right. So let's keep going. We're on number 14 now. So for number 14, I'm going to write the equation for g of x that's formed by reflecting this equation across the x-axis, then horizontally stretched by a factor of by 6, and lastly translated 5 units to the right and 3 units down. This one is a little more straightforward. I have these transformations. I'm going to affect it on f of x, and we're going to see what we get. So the first thing I have is across the x-axis. I'm reflecting across the x-axis as a vertical reflection. That means that a is negative 1. So what I have is f of x is now going to become a negative 3, 2 over 3, x plus 2 squared plus 7. Anytime you do a vertical reflection, you're affecting all your y's. That's why your a becomes negative, and your k, which is a y coordinate, also gets affected by that negative. So it goes from negative 7 to positive 7. After that, I'm being horizontally stretched by a factor of 6. So that's telling me that my b is 6. So I take this equation I just had. I have negative 3, 2 over 3. So your b is 6, but you always put in 1 over 6. And anytime you do a horizontal reflection or stretch reflection or compression, you always want to put that 1 over b term right with the x. So I want to put it right on the x and just say it's 1 over 6x plus 2 squared plus 7. So the way I like to do it, I don't know how the other teachers teach it, but I say put the 1 over b right with the x, and then you factor it out, and that's when it affects the h. So put it in right with 1 over x. I'm going to factor out that 1 over 6. So what I get is 2/3 times 1 over 6, which is 2 over 18. And when you factor out that 1 over 6, you have that 2 divided by 1 over 6, or really just 2 times 6. So it becomes x plus 12. Everyone with me? Maybe other people who don't have me might be a little different. Did I do something wrong again? Yeah, it reduces. I still want to reduce it, by the way. It reduces it. Sorry? Which one? Guys, keep it down. Where you go? It's B6, right? Yeah, so I move it out. You see it? Go ahead. Go ahead and back. Go ahead. Guys, keep it down. 2 over 3 times 6 over 1. So you think that you put your b is 6, you put in 6, right? So you think when your b is 6, you plug in 6 into the equation, right? Remember the vertex form? That's y equals a of 1 over b x minus h. Remember that? So it's 1 over b. So if I'm stretching about a factor of 6 horizontally, that means my b is 6. So you put into the equation, it's 1 over b, which is 1/6. Yeah, 2/3 by 1/6. I'm factoring out 1/6. So once you put into the equation, it's just you have to treat it like it's a regular math problem. So I put in 1/6 because you put in 1 over b, right? When I factor out that 1 over 6, I have 2/3 times 1/6, which is 2 over 18. Right? Because I don't want a coefficient in front of x, right? Oh, okay. The h is kind of confusing, right? So anytime you factor something out, what you do, I'll make a new page. So if I have that 1 over 6, x plus 2, I'm factoring out that 1 over 6, right? So anytime you factor something out, what you're doing is you're dividing everything inside of it by what you factored out, right? 1 over 6x divided by 1 over 6, that's just x, right? If I have this 2, I'm taking this 2 and I'm dividing by 1 over 6, right? So that becomes 2 times 6, which is 12. Right? And another way to think about it, so another way to think about that right here is that I'm stretching it by 6, right? So I'm stretching by 6, and that h value that is an x value is being stretched by 6. That's why I went from 2 to 12. It's stretched by 6. Everyone okay with this? Any other questions? No? All right. And lastly, I'm going 5 units to the right and 3 units down. Guys, keep it down, please. 5 right and 3 down. So 5 right, that means I'm going to subtract 5. Remember, everything inside the parentheses, anything dealing with x is always a little weird. So what you end up getting is -3. That 2 over 18 you can reduce to 1 over 9. Then I have x plus 12. I'm going to the right 5. That's always going to be a little weird, so it's going to be -5. All squared plus 7. I'm going down 3, so it's -3. Everyone okay with that? Are we good? So what I get is -3, 1 over 9, x plus 7 squared plus 4. That's your final answer. So we got? Yeah, I'm proud of you. Good job. Yeah. Proud of you. That was a hard question. It's confusing. Me? I try to do all the steps to show what's happening. Maybe I do overcomplicate it. I'm just trying to show exactly what's happening. Me? Yeah, I'm not trying to show any mental math. I want y'all to think I'm skipping steps. I try to show every step. If it's confusing, I'll try to stop doing that. That's what I'm trying to do. Exactly. Right. All right. Any questions here, guys? Are we okay with that? Are we good, guys? Before we move on. No? Okay, let's keep going. So 19, what is f of x in vertex form? So for this one, I want to complete the square. All right. So to complete the square, guys, keep it down. To complete the square, you want to isolate the first 2 terms first. That should always be your first step. So isolate the first 2 terms. And then remember, I don't want a coefficient in front of x squared. So I'm going to factor out that -2/3. So when I factor out that -2/3, I have x squared. And then I have 16 over 3 divided by -2/3, which is the same thing as 16 over 3 times 3 over 2, or -3 over 2. So you end up getting -8x. All right. And then from there, I'm going to add some blank. And I have plus 7 over 3. And I'm going to have another blank I'm going to subtract from there. So remember this first blank, that's always your b term divided by 2 squared. And your b is -8. So what I end up getting is -2 over 3 times x squared minus 8x. -8 divided by 2 is -4. -4 squared is 16. And I have plus 7 over 3. And remember, I'm putting in the 16. So I need to balance it out by subtracting what I put in. So I have this 16 with this -2/3. So it's negative 2/3 times 16 gives me a negative 32/3. So I put in a negative 32/3. I need to subtract a negative 32/3, which is just adding negative 32/3. Everyone with me so far? Are we okay? No? What's wrong? So remember, what you always want to do is you always want to balance out the equation, right? I can't just add a 16 here without subtracting it on the outside, right? But I'm not putting it into thirds. I'm not doing that. But you see this negative 2/3? This is multiplying everything inside the equation. Everything inside those parentheses, negative 2/3 is multiplying. So it's not just a 16 that I put in. I put a 16 times negative 2/3 on the outside. Yeah, well, on the inside is what I put in, but I need to subtract on the outside. So what I'm going to do is subtract that negative 2/3 times 16. Because this right here is really what I put in when I put in that 16. And then this x squared minus 8x plus 16, that factors to x minus 4, all squared. And then I have plus 7/3, and that's going to give me a positive 32/3. Any questions so far? Are we okay? Everyone doing good? No? What's wrong? You're going too fast? I'm sorry. So it's either I'm going too fast or I'm overcomplicating. Which one is it?
Well, I understand the overcomplication now. Now I know that I get it right again. But
All right. I'm going to try to speak slower. All right. Maybe you need to listen a little faster. I don't know. All right. So this is what I have right here, right? So I have negative 2/3, x minus 4 squared, plus 7/3, plus 32/3. So if x minus 4 squared, 7/3 plus 32/3, that's 39/3. And that just reduces to 13. That's the answer. Are we okay with that? Is there any questions about anything I did here? Have a nice day. Are we good? Just keep it down. Stop fighting with each other. Stop touching each other, please. Not in my classroom. All right. Are you ready to keep going, guys? Okay, let's keep going. You have 3 more problems, and I want to go home. No, not me. What? What are you trying to imply here, Dennis? I have a wife. I have to go to the gym. I have a lot of things to do when I get home. I go to the gym. No, 4 times a week. 4 times. Yeah, I'm charged the post. I have no clue, to be honest with you. Yeah, we're off track. Yeah, guys, we get back to this thing. I want to get this over with. All right. My what? My what? No, I'm good. I'm gonna get this over with. All right. So, number 22. We're on number 22 in the homework now. Where's the graph of f of x equal 5x squared plus 50x plus 19 increasing? So when is it increasing? To know when it's increasing, you need to figure out what your a value is and also what your h value is going to be. So here, finding your a value is pretty easy. That's your 5. The leading coefficient of x squared, that's your a value. So I know a is 5. So I know that a is going to be positive. So I know I'm opening up. That part I know. But now I need to figure out, well, what's my h value, right? What's my vertex or my h value? So to figure out my h value, you could complete the square here and figure that out. That is an option. The easier way is to remember that h is negative b over 2a. That's the other way to go about it. So what I get is that h is negative b or negative 50 all over 2 times 5, which is 10, which is negative 5. What? So if you want to complete the square, if we finish this problem, I'll solve it completing the square too. Okay. So I have h value of negative 5. So I know that the x value of my vertex is negative 5. And to be honest, I don't care for the k because all I'm asking for is where am I increasing? So I'm increasing from my vertex to infinity. So from -5 to infinity. Go ahead. Anything? Yeah, anything you don't find your h value, you can just -b over 2a. Yeah, so in this problem here, when I'm asking, when I just want h, I can just use this. There are some times where completing the square is easier. You need to do it. Guys, keep it down, please. Guys, keep it down. Keep it down. So there's sometimes where you actually need to complete the square because you need both the h and the k. And in my opinion, when you need the whole vertex, h and k, I would just complete the square and get it done one time. All right. So let's say you guys forgot you forgot this equation that h is -b over 2a, and you need to solve it by completing the square. So we're gonna do that. All right. So to complete the square, I'm gonna isolate the first two terms first. That should always be your first thing to do is complete the square, isolate the first two terms. And then you're gonna factor out that 5. Factor out that 5. You have x squared plus 10x plus some blank plus 19 minus whatever you put in. Right, so guys, keep it down, please. So this first blank is b divided by 2 squared. So 10 divided by 2 is 5. You square it, that's 25. And I'm going to subtract that 25 times 5, right? Because that's what I really put in was that 5 times 25 or 125. So I need to subtract 125. But to be honest, that part isn't that important. What is important is your h value. And that factors the x plus 5 squared. So you get -5. And that is, what is that, 106? Yes. Yeah, so whatever you put inside the parentheses, you multiply it with your a, and you subtract it outside. So I saw in the previous problem, it was a negative. It was minus a negative number. It ends up working itself out. Right? Guys, keep it down. So in this type of problem, honestly, if I was doing this problem, I wouldn't have even bothered doing this part. I would have just completed the square here. I don't care for it, right? My question is really saying, where am I increasing? If you can answer that question, I don't care for the k because it's not part of the question, right? Right? So b divided by 2 squared. 10 divided by 2 is 5. 5 squared is 25. Here. Are you sure? Good. Guys, keep it down. So that 25, you got b over 2 squared. Yeah, and this 125 is at 25 times 5. Everyone with me so far? Are we okay? Any questions? No? Go ahead, Sonny. I'm not taking questions, but I have my own problems to do. Yeah, so sorry. At this time afterwards, I'll help you. All right, ready to keep going? Guys, stop talking. On to number 9. 23, what did I say? 23. We're on slide 9, number 23. I think so. All right, 23. So on number 23, a projectile is fired off a cliff, so its height is in feet is modeled by the function h of t equals this, given t in time is time in seconds. How long will the projectile ascend? So usually on the quiz and the test, it will give you this formula, but you guys need to understand what does each part actually do. Right, -16, that part isn't too important. That's just the gravitational pull or whatever it is. It's not that important. 80, that's just your initial velocity. And that 576, that is kind of important, especially when you're trying to draw a picture. 576 is your initial height. So like if for some reason I wanted to draw this picture, that 576, that's telling me where I started the whole thing. Right, so something got thrown off, whatever it is. That 576 is telling you where you're starting or what your value is at 0. But you don't really need to draw a picture for this problem because all it's asking is how long would the projectile ascend? So how long am I going up? Well, remember, it's in a quadratic shape. So I'm going to go up until my h value. So all I really need to figure out is, what is h? So to figure out h, I'm just going to, well, you could actually do this formula right here if you wanted to. Or you could complete the square. I'm going to complete the square this time because I actually want to add a second part to this problem. I want to figure out what the maximum height is going to be to. Okay? So I'm going to complete the square. The first thing you should always do, isolate the first two terms. So isolate the first two terms. Then you want to factor out that negative 16. So I have negative 16 t squared minus 5t plus some blank plus 576 minus some other blank. All right. So that negative 5, I'm going to divide it by 2, then square it. That gives me 25 over 4. So when I factor it, I have negative 16. That becomes t minus 5 over 2 all squared. And I have the 576. Are we good or am I going a little too fast? Am I good or are we going too fast, guys? Go ahead. Right here? All right, so this part right here, let me back up. You got it? So this right here, the whole point, guys, so keep it out. The whole point of completing the square is so that whatever's in the parentheses can factor out to t plus b divided by 2, all squared. The whole point of completing the square is so that I can factor out the parentheses into this form. So that's how I got 5 over 2, or negative 5 over 2, is because I completed the square, and so that parentheses factors out into that. So negative 16 t squared minus 5 over 2 squared. And then I have that 576. And I'm going to subtract my a value of negative 16 multiplied by that 5, or by that 25 over 4. Right, remember it's from this 25 over 4 before you factored it out. Sorry? Twice. That's an accident, I'm sorry. There we go. Are we good here? Any questions so far? So from here, I have negative 16 t minus 5 over 2 squared plus 576, and I have negative 16 times 25 over 4. That's going to give you negative 100 or positive 100. You're going to get calculators tomorrow, so you can figure that out by yourself pretty easily with a calculator. But anyway, when you factor it all out, you have negative 16 t minus 5 over 2 squared plus 676. Everyone with me, or am I going a little too fast? Are we good? Any questions so far? All right. So the original problem is asking me how long did I ascend for? So how long did this projectile ascend for? 2.5 seconds, right? Because it's that 5 over 2. I'm basically asking, what's your vertex? So it's 2.5 seconds. And something else I want to add to it, it's what's my maximum height? 676. So your H term for the vertex, so if I go back to the picture I drew from the very beginning, this vertex is 5 over 2, 676. So that's telling me both how long I'm increasing by and also what your maximum value is going to be. So my maximum is 676, and I'm increasing for 2.5 seconds. Are we okay with that? What's wrong? 2.5. 2.5 is the answer to the question that we put, but I wanted to add an extra part, and I wanted to ask you guys, what is the maximum height? The maximum height is 676, your K value. Any questions about this problem before we move on? We're good? Great. All right, number 10. 28. I'm sorry, 28. We're on slide 10, number 28. You can come up here and teach this one if you want. You know this one yet? All right. So number 28. Find the quadratic that has an axis of symmetry of x equals -7 and passes through both these points. So anytime we say we give you the axis of symmetry, remember your axis of symmetry, that's x equals h. So when we give you the axis of symmetry, what we're really giving you is just your h term. So I know h is -7. So then from here, I can put it into my vertex form of y equals a x minus h squared plus k. Or y is a times x minus -7 or x plus 7 all squared plus k. All right. So I have two unknowns, right? I need to figure out what's my a and what's my k. And that's why we give you 2 points. We have two unknowns, and we can figure out our two unknowns from these 2 points because it gives us 2 equations. So for -9, 10, I can plug in the 10 and -9. So 10 equals a times -9 plus 7 all squared plus k. Right, it's x minus -7, so x plus 7. So 10 equals some a. -9 plus 7 is -2. -2 squared is 4 plus k. And now I'm going to do the same thing for -3, 1. So I have 1 equals some a of -3 plus 7 all squared plus k. 1 equals a. -3 plus 7 is 4. 4 squared is 16. All plus k. So they gave me 2 points, and I'll put them both into my equation so I can have 2 new equations. And both these 2 new equations are going to help me solve for my 2 unknowns, right? If I have 2 unknowns, I need 2 equations to solve for them both. So from here, I'm going to make a system of equations. So what I get is 10 equals 4a plus k, and that 1 equals 16a plus k. So I have a system of equations, and what I want to do is either add or subtract or whatever I can do to cancel out one of the variables. The k's have the same coefficient, so I can just subtract these from each other. 10 minus 1 is 9. 4 minus 16 is -12a. The k's cancel out. I can divide by -12, and I get 9 over -12 equals a, which reduces to -3/4. So a is -3/4. All right, so a is -3/4. And what I want to do from here is take that a value, and I'm going to plug it back into either the red or the blue equation. It doesn't matter which one, because I'll see you tomorrow. It doesn't matter which one because it's going to give you k either way. So I'll plug it into the red one, but it really doesn't matter which one you choose. So 10 equals 4 times -3/4 plus k. 10 equals -3/4 of 4 is going to give you -3 plus k. Add the 3 over, k is 13. Everyone okay with this? Are we okay? Any questions, comments, concerns? Go ahead. Sure. Is that fine? Or is that too small? Is that fine? Okay, go ahead. Yeah. So the whole point of a system of equations, guys, keep it down. The whole point of a system of equations, guys, is to cancel out a variable so that you can plug it back into the original. So yeah, you just plug it back into either one, you solve for k, you're good to go. Go ahead. It doesn't matter. Yeah, once you have your a value, you can solve it however you want to. You can go back to the original equation, plug it in, because the whole point of the equation of getting the a is that you can plug it back to the original equation. You can get rid of all the other variables, so we can just solve for one. Guys, keep it down. Oh, so you multiply it by -4 to cancel out the a's and solve for k. Yeah, you can do that too. It's harder, but you can do it. I wouldn't care if you did it that way. That's fine. All right, so k is 13. I see you plug everything in. So my final answer is y equals my a of negative 3/4. X, what's my h? Negative 7, so x plus 7. All squared plus 13. That's your answer. Any questions about that? Does that make sense? Are we good, guys? Good? I'm finally free. All right.